Imagine a time machine, not one made of gears and flashing lights, but one made of gold-plated mirrors, sailing silently through the void of space. This is the James Webb Space Telescope, or JWST for short. Launched on Christmas Day in 2021, it is humanity's most powerful eye on the cosmos. Its mission is simple yet profound: to look back in time. It seeks to witness the very first flickers of light that pierced the darkness of the early universe. The JWST is an infrared telescope, which means it can see the kinds of light that are invisible to our eyes. This special ability allows it to peer through cosmic dust clouds and capture the faint, stretched-out light from the most distant objects in existence. Why is this so important? Because light travels at a finite speed. When we look at the sun, we see it as it was 8 minutes ago. When we look at the Andromeda Galaxy, we see it as it was 2.5 million years ago. The farther we look into space, the deeper we look into the past. The JWST was specifically engineered to look so far away that it can see the universe as it was just a few 100 million years after the Big Bang. It is designed to answer some of the biggest questions we have ever asked. Where did we come from? How did the first stars and galaxies form? We are, quite literally, searching for our cosmic origins. This incredible instrument is a testament to human ingenuity and our unyielding curiosity. It orbits the sun 1 million miles from Earth, a cold and lonely outpost where it can keep its sensitive instruments cool and shielded from the sun's glare. From this vantage point, it stares into the abyss, collecting ancient photons that have traveled for over 13 billion years to reach its mirror. Each image it sends back is a postcard from a bygone era, a piece of the puzzle of cosmic history. This telescope isn't just looking at stars, it's looking for the very first stars that ever existed, the ones that started it all. The universe wasn't always filled with the glittering tapestry of galaxies we see today. For millions of years after the Big Bang, it was a dark, uniform sea of hydrogen and helium gas. This period is known as the Cosmic Dark Ages. The JWST's primary goal is to see what happened at the end of this era, to watch the moment the lights turned on across the cosmos for the very first time. By capturing this ancient light, we hope to assemble a baby picture of the universe, revealing the processes that eventually led to planets, life, and us. It is a grand and ambitious quest to understand our place in the grand cosmic story. So, what exactly are astronomers looking for in these ancient cosmic shores? They are hunting for ghosts. These are not supernatural spirits, but a theoretical class of stars known as population 3 stars. These are the universe's firstborn stars, the pioneers that lit up the cosmos. They are called population 3 because astronomers had already classified the stars we see today. Population 1 stars, like our sun, are rich in heavy elements. Population 2 stars are older and have fewer heavy elements. But population 3 stars? They would have had virtually none. They were forged from the raw, pristine material left over from the Big Bang, almost pure hydrogen and helium. Finding these stars is one of the holy grails of modern astronomy. Because they were made only of the lightest elements, the physics of their formation was completely different from stars today. Theory tells us they would have been titans, absolute monsters of the cosmos. They could have been hundreds or even thousands of times more massive than our sun. And with that great mass came a brilliant but tragically short life. They would have burned incredibly hot and shone with the light of 1 million suns, blazing through their nuclear fuel in just a couple of million years before exploding in spectacular supernovae. These first stars are more than just a cosmic curiosity. They are the chemical factories that transformed the universe. Everything you see around you, the carbon in your body, the oxygen you breathe, the iron in your blood, was forged in the heart of a star. But those elements did not exist at the beginning. The Big Bang only created hydrogen, helium, and a tiny bit of lithium. It was the population 3 stars that began the process of cosmic enrichment. When they died, they seeded the universe with the first heavy elements, the raw materials needed for the next generation of stars, for planets, and eventually, for life itself. Looking for population 3 stars is like searching for a needle in a cosmic haystack. Because they lived such short lives, they are all long gone. We can't see them in our own galaxy, or even in nearby ones. The only way to find them is to use the JWST to look incredibly deep into space, and therefore, far back in time. We have to look to the edge of the observable universe to catch the light from galaxies so young that they might still contain these primordial giants. It's a painstaking search for the faintest of signals from the dawn of creation, a quest to witness the birth of starlight itself. How can a telescope, even one as powerful as the JWST, see something so far away and so faint? Astronomers have a secret weapon, a trick provided by nature itself. It's a phenomenon predicted by Albert Einstein's theory of general relativity, called gravitational lensing. Einstein showed that massive objects, like a galaxy, or a huge cluster of galaxies, can warp the very fabric of spacetime around them. This curvature acts like a lens, a cosmic magnifying glass. When light from a more distant object passes by this massive cluster, its path is bent and magnified, making the distant object appear brighter and larger than it otherwise would. This is precisely the technique astronomers use to find hints of population 3 stars. They pointed the JWST at a massive galaxy cluster known as MAX J0416. This cluster is like a giant lens in space, and by looking through it, astronomers could see the faint light from galaxies lying far behind it, galaxies from a time when the universe was less than 1 billion years old. It's an extraordinary alignment of cosmic proportions. Without this natural telescope, the light from these incredibly distant and primitive star-forming regions would be far too faint for even the JWST to detect directly. Gravitational lensing gives us the boost we need to push our vision deeper into the past. In one of these lensed galaxies, a small, compact region caught the scientists' eyes. The light from this region carried specific clues that pointed to something extraordinary. To confirm their suspicions, they had to check off a list of criteria. First, the environment had to be extremely metal-poor, meaning it had very few elements heavier than hydrogen and helium. The JWST's instruments can analyze the chemical fingerprint of light, and the data showed this region was indeed pristine. This was the perfect kind of nursery for population 3 stars to be born in, a place untouched by previous stellar generations. Second, the stars had to be forming in a specific way. Theoretical models predict that these first stars would form in small, dense clusters. The observations from the lensed galaxy matched this expectation, showing a concentrated burst of star formation. Finally, the type and mass of the stars had to align with predictions for population 3. The light signature suggested the presence of incredibly massive and luminous stars, far bigger and brighter than what we see forming in the universe today. All 3 clues, the pristine environment, the cluster formation, and the massive stars, pointed to a monumental conclusion. The JWST may have finally captured the light from the universe's first stars. This discovery, if confirmed, is a game-changer. It's like finding the first chapter of the story of how galaxies came to be. We believe that these giant population 3 stars were the seeds around which the first small proto-galaxies began to form. Their intense radiation would have ionized the surrounding hydrogen gas, clearing it out and shaping the structure of the early cosmos. When they exploded, the heavy elements they spewed out enriched the interstellar medium, allowing smaller, longer-lasting stars, like our Sun, to eventually form. Seeing these stars in action provides the first direct evidence for this fundamental step in cosmic evolution. Understanding these first stars helps us solve the mystery of where the elements came from. The story of the universe is a story of increasing chemical complexity. We started with only hydrogen and helium. Today, we have a periodic table full of diverse elements. This discovery shows us the very first link in that long chain of creation. It confirms that massive, short-lived stars were the engines of this process, churning out the building blocks for rocky planets, atmospheres, and all the ingredients necessary for life as we know it. We are, as the saying goes, made of stardust, and this discovery takes us back to the very first factories that made that dust. This is just the beginning of what the JWST might uncover. This finding gives us a specific place to look and a method to find more of these primordial objects. Scientists will now hunt for similar signatures in other distant lensed galaxies, hoping to build a larger sample of these first light regions. Each new discovery will refine our models of the early universe. We want to know, how massive were these stars really? Did they always form in clusters? How did their explosions influence the birth of the first black holes and the growth of the first galaxies? These are no longer just theoretical questions. They are questions we can now realistically hope to answer with observation. The universe is telling us its story, and for the first time, we have a machine capable of reading its earliest pages. This potential glimpse of population 3 stars is more than just an astronomical headline. It is a profound connection to our deepest origins. It fills in a crucial blank in our understanding of the cosmos, from the Big Bang to us. The journey of discovery continues, and with the James Webb Space Telescope as our guide, we stand ready to witness even more wonders from the cosmic dawn, pushing the boundaries of knowledge and our place within this vast, beautiful universe.